Hello everyone. So in today's video, we'll discuss more about um, marginal and conditional distributions. Let's get to that real quick. So now what are marginal and what are conditional distributions? Let me just give a specific, uh, let me just teach you. So marginal and conditional distributions are, conditional means is the, yeah, conditional means it's something like that's depending on a condition. So like here, if we want, not we want all the freshmen, but we want only those that have dressed for the spirit week. Okay. Not dressed normally, that's called a conditional distribution. Depends on some condition. Okay, it's not something like I just want all of it. I just want this whole variable. I just want that whole variable. I want some this variable depending on if that other variable is true or not. Like in this example, if you see, each day of Spirit Week at Alex School, students have the option of dressing up according to their different team. Tuesday of Spirit Week, Alec recorded the number of students at a school by class and style of dress. Here's his data. So there are like four adult students, right? In just a school, like a freshman, sophomore, junior, senior. Like university. First year, second year, third year, fourth year. Then we have like dressed for Spirit Week. Some dressed like for the Spirit Week, especially Spirit Week themed costumes they kind of wear. And some are just kind of dressing up normally, just a normal clothes. So here we just see that, 175 freshmen um they dressed for the Spirit Week, whereas 73, see here, they dressed normally. So if I said I want all the freshmen for the Alex school in the week, I mean on Tuesday of Spirit Week, I just want all of these freshmen students. That means it's a marginal distribution. I just want the whole variable as it is. No conditions, no second thoughts, just the variable as it is, without any filtering. Just plain directly. I just want authentic variables, you could say. I just want directly the variable as it is. Want any filters? That's called a marginal distribution. If we want a conditional distribution, that means we have a specific condition. So we have freshman, and if that person has been dressed for a spirit week, then we kind of have to follow up for a condition. So that's our condition, that's 175. Okay, that's my margin, that's my conditional distribution. So here we see what is the best distribution of the description of the box of the distribution boxed in the last column of the table above. Okay, now this one actually is, what do we say here is, this one, remember, this is not saying I want the freshmen who are dressed normally or who are dressed like for the Spirit Week. I want the seniors who are dressed normally. I want the juniors who are dressed for Spirit Week. I want all of the freshmen. Okay. What is it saying? It's saying that all the freshmen, all of the sophomore, all of the junior, all of the senior, all the total. That's it. I just want the total. That's it. What do I say? This is the marginal distribution of what? It should be the style of dress if it was, because we have two options, okay? We have two options that say marginal distribution. Conditional it can't be because it's not a condition, it's just directly the variable without any filters. The variable has filters, that means it's conditional. The variable has no filters, it is marginal. So if I say how many dressed for the week, or like if I want how many dressed normally, these two. That is also marginal. But if I say how many dressed for dressed normally, but they were sophomore, given that they should be sophomore. So that is kind of a condition I have. It's conditional. So here if you see this 248, 198, 231, 180, all of those, four categories, they are specifically matching to the class right there for the freshmen. So how many freshmen I have? 248 for this Tuesday, 198 sophomores, 231 juniors, and 180 seniors. Means I should be having this as the senior distribution of the class. Yes. Not senior distribution of style of dress. Style of dress will be 696 and 161. That's style of dress, for the spirit week, if they're dressing up for the normal dress, normally just wearing clothes, normal and regular clothes, or are they just dressing up for the spirit week? But here we see they're not dressing up for any special event, they're just dressing up. I mean, like either way, they're just dressing up, but they are belonging to the specific class. Means it's a marginal distribution, it's a class. There we go. Even if you see the solution, yeah. The boxed column, yeah, shows frequency of different classes. Yeah, they just show frequencies of different classes. Okay, the total we know is 857. The 248 out of 860 out of 857 are freshmen. Then 198 out of 857 are sophomore. One out of 857 are junior, and 180 out of 857 are senior. Anyways, we know it's gonna be for the class. It's not a different style of dress. And then marginal. So marginal, this is describing the totals of the class. Yes. So this means it should be a marginal distribution. Okay. At the edges, if you see the totals, that's generally the marginal. If you see like in the middles, it's generally unconditional. Okay, Ajay has been recording his outcomes for 3 games that he has played this summer. Here is his data. His data. So that's all his data here. JS, checkers, Mangala in total. These 3 games, and then the total they just give us wins, losses, total stuff. So he's just kind of playing. Sometimes he's losing, sometimes winning, and then they just have a mosaic plot. I think it's a mosaic, right? Yeah, it's kind of a mosaic one. And they're just giving a graph. The distribution is shown below. I don't think it's looks like a mosaic one. I'm not sure really. This is I think it looks like a mosaic one, but I'm not sure. But anyways, let's take a look at the options below. Let's see what does this represent. What does this mean? So I think wait, this should be more of a. Let me just confirm. This is a mosaic. Just a minute. Let me move this to the right. Yeah. Okay, yeah, okay, I see. I think I just got confused. Yeah, it's a stacked bar chart, they call it. It's like a relative frequency stacked bar chart. They use it like a y-axis, the relative frequency is being given, and then the total is being given. Like the totals is being graphed here. So yeah, for the chess, checkers and Makala. So of the total games, how much did they compose? So I think chess is about like nearly 30, little bit more than 35 or something up here. And then yeah, this is basically the chess is I guess sorry, chess is up here. This is checkers. This is Minkela. Okay. So yeah, they're just graphing up the relative frequencies compared to the total. From here we can just kind of see like from out of 100% how much they're taking up. How much like how many games are dedicated to. So like 37, 13 are chess. So 13 out of 37, that many percent of games played total were from chess. Either wins or losses with chess. So now here when they say you have which distribution is shown below. So what do we say here? Which distribution is shown below? It's shown up for the games, right? Because chess, checkers, and make a lot of games. They're not wins or losses. And whether regardless of whether it's win or loss, it's just showing us data for the game. It means what it should be? It should be the marginal. Yes, it should be the marginal. And what of marginal of game played? Yes. Not depending on condition. It's just depending on the variable. So therefore it should be game played. There we go. Yeah. As you can see from the legend, this is the distribution of game played. Checkers, chess, Magellan, not above. Yes. Awesome. It describes the total. So yes. Now, each day of Spirit Week at Alex School, students have the option to dressing up according to a different theme. On each day of Spirit Week, Alex recorded the number of students at his school by class self-dressed. Here's this data. So this is the data up here. Freshmen, and then they just gave the dressed normally and then the total. So now they're saying what is the best distribution of the distribution box in the second row. Awesome. Yes. This one is actually where we really need to focus on. In the second row of the table above. Yes, boxed in the second row. So this is our second row. Now here they're saying what is sorry, I think what is all of this data up here graphed? Now this is specifically showing us what? This is showing us the conditional. Yes, because this is highlighting dressed for the spirit week, given that they're freshmen. Okay, they should be freshmen. How many freshmen dressed for the spirit week? How many dressed freshmen are dressed normally? It's a conditional distribution. For what? Conditional distribution of class for students dressed normally. Yeah, this one might seem confusing. Might seem like an option because dressed normally does no, but it actually shows spirit of week and dressed normally both of. So well, we could say conditional distribution of style of dress. I think style of dress makes more sense. It shows a conditional distribution of style of dress. Like our freshmen, how many dress normally, how many how many wearing orange shirt versus how many wearing a blue shirt, how many wearing a green shirt, like that. That's conditional distribution. That means the style of dress for freshmen. Okay. Yep. Here we see. The given distribution shows the frequency of each style of dress, given that a student is a freshman. Yes. Since we're looking at the frequency of each style of dress for freshmen, all students shown in the total column, that's going to consider a conditional distribution. Not looking at the total, we are looking at the frequencies for each style of dress. Only for freshmen. You're not looking for all of them. For all of them, it would be like total number of people who dressed as normal people or just dressed for the spirit week. That would be considered a marginal distribution. But here it's like for a specific condition, it's conditional. Okay. Awesome. James. James is interested in the relationship between weather conditions and train delays. Okay, awesome. And then for a year, James is recording the conditions each day as well as whether this train arrives on time or is train delayed. Here are his results. Interesting. Okay, this one is saying now graph of distribution is shown below. Okay, this is also stacked bar chart, but now what is this basically saying? This is saying sunny, cloudy, rain, snowing. Okay, this is based on the weather condition, not on the time or delay. Regardless of whether it's being time or delayed, how many trains are, operating? How many trains are operating, whether on time or delayed, whatever. Operation may be delayed, operation will be on time. But there is an operation. How many operations are in sunny? How many operations are in cloudy? How many operations are in rainy? How many operations, last but not least, are in snowy weather? So here we see, it should be like basically where we have totals without any conditions. That should be a marginal. Marginal means it should be marginal of weather conditions. Yes, not of arrival status, but of weather conditions. If it was of arrival status, it would be 330 and 35, not 170, 120, 55, and 220. So yes, that would be, there we go. Awesome. Well, let's do the next exercise. Okay. James is interested in relationship between weather conditions and whether the time train runs on time. For a year, James records the weather each day as well as whether this train arrives on time or is delayed. Here is this ones. So he's being interested, on the weather conditions and whether this downtown train is going, if it's running on time or not. It's kind of modeling the relationship. It's kind of interested in that stuff. So it's kind of recording, the weather. He's recording the weather, and then he's even recording the train, whether the train arrives on time or not. And then here, they're just displaying the data here, like weather condition, and then whether the train was on time or delayed, like the last problem. And they're saying, what is the marginal distribution of arrival status in gaps? So yes, marginal means total. Marginal means total. Marginal equal to total. Conditional equal to condition. I have a condition that this must be true. Marginal means the total for this. Yes. So marginal equal total. That, kind of a phrase you can just keep in mind. Um, Kind of like a short phrase you can just remember. Marginal equals total. Now, marginal distribution of arrival status in gaps. What do we say? On time, how many were on time? If you see, it's 330, right? 330 are on time. The later, how many? 35, yes. Regardless of which weather it was, we just want the marginal distribution of arrival status, regardless of the weather condition. There we go. Okay. Here is a table giving the thousands of commuters in Alabama, 2015, by transportation method and one-way duration of commute. So this one is showing like thousands of commuters in 2015 in Alabama, in the state of Alabama, in the United States. A transportation method, and then the one-way duration of commute. So this one is saying is commutation duration, and they're saying one-way duration. Yeah, so one way, like just one way, how much time they're taking it. So, and then they're just saying by transportation method. So transportation method could be like, oh yeah, public transportation, or yeah, I think private vehicle. Okay, okay, I see. I think transportation method you're saying like private vehicle, how many went by, how many went in public transportation, and then yeah, so it's something like 2000, I think. Oh wait, what do they mean? Okay, I see. I think their meaning is thousand. So this one they say is 498 is 498,000, close to half a million. That's like a three-quarter million, right? Because it's 748,000, like thousands of commuters. So yeah, I think it should be in thousands because they're saying those given the thousands of commuters. So I think they're showing basically in thousands. This is also thousands here. So yeah, so like 1.90. So yeah, 198.38 and then 000. You just get like a, yeah. So 1.9 million approximately. Then about the marginal distribution of one-way duration of commute in percentages. So yeah, they're just asking us marginal distribution. So now private vehicle versus public transportation versus other. They're just using different sorts of transportation, but they're saying in total that these many people are less. Their one-way trip was 526. I mean, like less than 15 minutes. How many people took? About like 526,000, close to half a million, like regardless of the transportation method, whatever it was, like another way, other way, it was like private vehicle, public transportation, or whatever way they did less than 15 minutes. That's what we are considered with. So less than 15 minutes means how many? 526 out of 1938. So yeah, 526 out of 1938. You see that? Should be about 27. Let me just move this up here. Let's close that. Yeah. So yeah, now here they want us to do is less than 15 minutes. Now how much percent should be here? Round to the nearest whole percent. So it should be something close to 27. You can just say 27 up there. Now 15 to 29 minutes. That is about 758. So 758 divided by 1938. So 758. Let's try that. 758 divided by 1938. That should be 39%. That should be 39%. Yes. And then this one should be 30 to 44 minutes. How many 30 to 44 minutes is 393? Yes. So 393 we just write over here. 392 divided by 1938. That is about 20.27%. That's 20%. Yep. And then 45 to 59. So how many took like your long commute there? So 115. Okay. And then when we keep going longer commutes, well, less people take them because longer commutes aren't that interesting. So Most people wouldn't bother with longer than shorter. Shorter ones like less than 15 minutes are pretty neat. More than an hour, it's like gets boring. So okay, this one is about 5.9, right? Yeah. So I think we can just close to 6%. Again, the 60 minutes are about would be about. I think I'm sorry, guys. Oh, I'm sorry. I'm sorry. This one actually should be 6%. Yes, because this one is 150. Yeah, and then 45 to 59 is 146. 146. Yes. So it should be 146. So yes, yeah. So it should be 7.5%, which is about 8%. I think if you round two. If you try to add all of these percentages, we should be able to reach 100%. So that is our goal here. So if you try to let me just use the zoom pad. Yeah. So we try to add all of these percentages. Let's try that out here. So 50. So we try that out. 27. 27 plus, what is the number? 27 plus 39 plus 20. Plus 20. Plus 8 plus 6. Sorry. Yeah. 100. There we go. Yes. 100% we get in total. Yes. Let's check that. We will get it covered. Awesome. Okay. Let's check the step-by-step solution. So now that otherwise we can just see here. So yeah, that was they're just saying is yes. How many commuters had a commute percentage of less than 15 minutes and how what percentage commuters were between these many minutes and so on, so on and so forth. So basically, that's all we wanted to do here. We just wanted to find in what percentage out of the total, how many percentage of the total commuters did like in the commutation in how many number of minutes. Like if they did in 15 minutes, if they did like in 30 to 44 minutes or something like that. That's basically what they wanted to find out. And based on that, we can predict that how many, like what percentage of the people are taking more than an hour in travel, or what percentage of people are taking like half an hour. Half an hour they're spending about the time, like in traveling. So check here. Okay, let's go to the next one. Yeah. Okay. So yeah, now here they're saying James is interested in the relationship between weather conditions and whether the downtime trend rains out time. Same problem as before. For a year, James records the weather each day as well as the weather this time arrives on time or is delayed. Here are his results. Okay. Weather condition, on time, delayed, and total. Now we have sunny, cloudy, rainy, snowy. These are the four weather conditions. Okay, four. And then we have on time and delayed. Marginal distribution of weather condition in terms. Yes, what we do here is marginal distribution means total without any condition. So for the weather condition, for the sunny weather condition, we have 170 who did it, regardless of whether they were delayed or on time. 170 operations of the train. So clarity, how many operations of the train did? 120 well. For the other one, well, 55. And for the last one, is just 20. So yeah. So yeah, these are the train operations here. Yes. Now here we are to find its marginal distribution of arrival status in percentages. So arrival status is how much 330. So 330 out of 365. That is our on time. How many percent of the trains that are operating? Okay, operating in this weather conditions, different weather conditions, how many arrived on time. So all of the trains and all of the percentages, like for the whole year, what percent of the trains arrived on time, regardless of whichever weather it was. We don't want to see, we don't want to concentrate and focus on the weather. We just want to see what percentage did on time. That's so 90.4. 90.4 means 90, right? And then the other one would be 10, like because 100 we have total percentages. So yeah, the other one would be 10, but let's still just check 25 over here. 9.58, right? 9.58. And decimal points moves to ahead. So 9.58 meaning like 10%. 10% will be the delay. There we go. Okay. We did it. Okay. Let's move to the next one. Okay, this. Yeah. Okay, Lara is okay, conditional distribution. So this one is conditional distribution, meaning this one is based on the conditions. Okay. So here now we're going to be doing conditional distributions. Like Lara surveyed all of the grade 11th grade students at a school about the number of languages they speak, whether or not they have allergies. So here are the results. So, basically someone has speaking like two languages, someone speaking two languages. Some people are like trilingual, bilingual, some people like multilingual. So, some people like monolingual. So one language people are very common, just one language. And then, some people have like two, three, six languages. So here we could just say how many are total, how many of these students were total here. So which graph displays the conditional distribution of the number of languages spoken by our students with allergies. So yeah, this one is important. Now there's not saying just the number of languages. They're not saying like one, two, three, four, like six languages. We want the number of languages only for the students with allergies. That means we should be doing is yes. Now here, remember, we don't say like the languages here. We say allergies. Why? Because we want just the students with allergies. Now this one is indicating all of that stuff here. So if this allergies wasn't here, we would just say something like languages right? We could just something like, languages, as before, we said like languages or anything, we could just say like a label. We wouldn't say necessarily allergies, but here we have like, sorry, here we have like allergies as our condition. So that way, based on that, we want to see. So we don't avoid all of this data here. We want to avoid all of this. We just focus on this part. Okay. So on this part, we see. So now if we try to compare the graphs here, if you see, yeah. So now basically, if you see here, um, main bulk of the data who is taking up here. So most of the bulk of the data should be projected onto 25. Okay, one language means most people are monolingual. Okay, most people are monolingual, just English, just one language. That keeps things simple, but then it can really kill the diversity, really kill the diversity and like cadence the beauty of languages. So monolinguality will be just 25, just the largest, but 19 could be, the one after that. Two languages also like, bilingual is also common. Some people like, trilingual is a pretty rare. And there's, I think, six languages also extremely rare. Like six languages would be like, person would be like almost speaking so many languages. They would be having like a massive advantage, in many countries, like six languages in total. But 25, back to this question. So 25, you see, it's a small language. So 25 would be modeled in the lighter blue shade, right? So if you see here, that would be like a lighter blue shade, and it would be something close to, if you see 25 out of 47, that would be about less than like 25 out of 50 is basically 50%. 25 out of 47 would be something close to, I think, I guess 50. Oh yeah, it should be more than 50. Yeah, so it should be 53%. So it would be mostly bulk of the data coming up there. So yeah, light blue will be taking up there, that was space. And then if it just takes up to 53%, that leaves us with 43% down there, where two languages, right? Two languages is okay. This one is actually a little bit odd if you see, because this color is taking a lot of space, whereas three languages spoken just by two people. 2 out of 47 can be so big. So well, that really rules out the first option. So take a look at the second option. Okay, guys. So let's take a look at the second option here. Good enough. Yeah. Okay, so it's the second option if you take a look at, and here we can definitely see, okay, this one is taking small light color. This one is a little bit taking a little less because, here also 19 is a little bit less than 25, but it's not super less. 2 and 1 are pretty less. So yes, 2 and 1 will be taking, the smaller ranges, smaller chunks of the data at the bottom. They're just kind of sitting, puddling at the bottom. These kind of take up the other halves. So yeah, I think that's, this seems like a more plausible option. And yeah, there we go. Yeah, 53% to 40%, 4%, 2%. So yeah. Okay, Leon is trusted in relationship among geographic region and political affiliation. Leon collected data about political parties of US senators at a time in regions of the US that they represent. His rules are in the table below. Okay, so these are the regions here: Southeast, Southwest, West, Midwest, Northeast, Pacific, all the regions there, and then the political affiliation, whether he's a Democrat, whether Republican, whether he's an independent. So yeah, give the constitutional distribution of political party for the Northeast region. Yes, now this one is basically we want one for all the regions. We want just for the Northeast region. So Northeast, how many people are there in total? 22. How many are Democrats? 40. So 40 not at 22. Because here, that's about 64%. Like, let's say close to 64% are Northeastern Democrats. Yes. And then how many are Northeastern Republicans? The Republicans should be, I think it should be about 7%. So yes, that would be 32. 32, right? So 32 over there. And then we have about independent is close to one. Oh yeah, there's still a single independent person. That's about a 5%. So basically it's just round up to 5%. And actually, if you try to add all of these percentages, we should be getting like 63 plus 32 is how much? 96, right? So 5%. Hmm. Okay, I think, yeah, I see. They want us to nearest. Okay, let's put at the 10th. Let's not do like this. Let's actually put at a 10. So 63.6. Yes, 63.6. Let's do like that. See. Okay. Now let's try 7. So they want us nearest to the 10. So 31.8. 31 point. Let me, yeah. Uh, there should be 1, 4, 5. Okay, there we go. Now this one, if you try to add here, so if you just try to, add all of this data, let's try to add all of these questions here. So basically, if you try to add all of this 63.6 plus, let me go up here, 63.6 plus, what was the other thing? 31.8 plus 4.5. 9 point. Okay. They should be closer to 100%. So I think there is some mistake we did or something. Let me see. We go here. That should be 4 point. Let's make this 4.6 actually, because if you guys see it's 4.54, right? 4.545. So now this 5 cancels, make this 4 a 5, then becomes 4.55, then it becomes 4.6 at the end. I think it should be 4.6 instead. 4.6 makes more sense. Let's try that out. Oh, it's incorrect. Okay. Let's check that out. Let's try 4.5. Okay, I see. I think basically even if this doesn't add to 100%, I think they just want us to, yeah, get the solution as 4.5%. They just want approximation. Okay, I see. Okay, they just want approximations. They don't want to, get exact percentages. I think it's fine. Even if you got something like that. So, okay, same problem here. They're just getting the relationship between weather conditions and the weather rain, downdraft rain heat sometimes takes months of time. So now if you want to get the conditional distribution for weather conditions on delayed rains, what we do here is delayed rains, how many are there? Okay, so three. Now three delayed rains were sunny weather. So 25 a total. So 3 out of 35. Okay. Actually, by the way, let me just write 35. 8.6. And let's actually write percentages directly like that as it is. So we don't need to kind of add in, model around like that. So yeah, 5 should be like that. 14.2. 14.3 should be there. Yep, 14.3. Rainy should be how much? Rainy is actually, indeed, rainy is 15. So 15 out of 35. 42.8. 42.9. 42.9. Yes. 42.0. And some way should be, actually, some way is 12. So 12 out of, this time, 40, 34, 34.2, 34.3. There you go. Awesome. Okay, there we go. Okay. Now they want us to do this with other following interpretations are correct. Okay. First interpretation is saying when the weather was snowy, it was more likely for the rain to be delayed than on time. Yes, now this one is actually rule relative and column relative assumptions we can make because this one is row relative, column relative. This wasn't isn't like where it's being given as just for column relative or row relative. It's like given for both of us. So we can even go row relative, we can even go column relative. Column relative and row relative both frequencies we can get here. Okay. So which of the following interpretations are correct? You can just take here. So when the weather is snowy, okay. When the weather is snowy, let's check it out. So this part. It was more likely for the train to be delayed than on time. Yes, now this one is actually uh it was more likely for the train to be delayed than on time. This one actually makes sense. I think this one is correct because for all of them you see delayed is always less. Delayed is always less than on time. Like 3. 3 is less than 161. 5 is less than 115. 15 is less than 40. But 12 is actually definitely more than 8. So yes, this one's actually like this. And the other ones are like this. So yeah. That actually makes this statement true. It's actually more than 50% of the trains that were being delayed. I guess almost 60%. 12 out of 20. So given the train was on time, the weather was likely sunny or cloudy. So given that the weather was on time, the weather was likely sunny or cloudy, that's absolutely true. Yes, because that's bulk of the data. That's bulk of the data because rainy and snowy cause most of the delays, I think, I would say. According to real life also, that cause most of the delays. Sunny and cloudy is kind of mostly fine. So yes. So now most delays occurred on snowy days. Well, most delays didn't occur on snowy days. Most delays occurred on rainy days. Yep. There you go. So yes. That makes sense that A and B should be correct. A and C should be incorrect. There we go. Okay. Let us go to the next one. Bonus question. Okay, I think we just got incorrect, so we just got a question up there. So now Leon is just interested in the relationship between geographic bodies and molecular affiliation and galactic laws. They're up here, and then they're just saying is following interpretations are correct. Now here, given a senator was in the Republican Party, given a senator was in the Republican Party here, okay, senator in the Republican Party, they're saying the senator was more likely to represent the Midwest than any other region. Okay. They were more likely to represent the Midwest. Well. They were more likely to represent the Southeast, not the Midwest. Southeast is the most. So yes, this one is definitely incorrect. Okay. Given the senator is independent here, and it's certain that the senator represented the Northeast. Well, this one would be certain, yes, absolutely correct. Because senator is actually only in independent is actually only in the Northeast. So that and actually is correct. Now, given that the senator is representing the Southeast, it is likely that the senator is in the Republican Party. Okay, this one is saying that given the senator is representing the Southeast. Okay, Southeast means this part. It is likely that the senator is in the Republican Party. Well. This one would be actually correct. Yes. So B and C are correct. B and C. There you go. Okay. We did this. Okay. We can just move all the stuff here. Okay. Yeah. This one is basically on. Okay. I think this one is showing. Maybe you can just try this out. So this one is just showing like a small private college was curious about what levels of grade we're getting from straight A's. College officers collected data on the straight A status from the most recent semester for all the graduate and undergraduate students. The data shown in the two-way table below. Undergraduate graduate students straight as not. This distribution is highlighted below, whatever distribution this would be. So this one would be actually conditional distribution or wedge distribution. This is actually the marginal distribution because this is showing the marginals, right? These are just showing, 4,500 and 4,500 are actually showing like the totals, total of undergraduate, total of graduates. So this is marginal distribution of student level. Yes, student level. Perfect. There we go. What conclusion can we draw from the highlighted distribution? We can draw that there are far more students with straight A's than there are without straight A's. Well, nope, that is incorrect because there are actually only 300 students with straight A's. There are not actually 4,200 who didn't get an A. Then getting an A is a little bit harder, so most students wouldn't be there. There are far more students than without straight A's than with straight A's. Excellent. Actually, exactly right. Okay, but that is actually a correct statement, but from the highlighted distribution, what can we draw? So this one is correct. B is correct exactly. As I said, like B is correct, but from the this thing, like highlighted one 4,500 and then 4,000 in the undergraduate and 500 in the graduate, what can we draw? So from that we can actually draw is there are far more undergraduate. Yes, there are far more undergraduate than graduate students. That is actually yes, that is true. So B and C are true, but yeah, C is actually bringing true because we are just highlighting that final line, final column, final. I mean row. Sorry, final row. That is the horizontal thing. Then there are far more graduate students, undergraduate students. That is actually incorrect. So yes, there are far more actually undergraduate students than graduate students. There we go. Check. Okay. Officials at the college are curious when the level of students more likely to get straight A's than the other. Look at the conditional distribution for straight A's for each level of student. Okay. So here we want to calculate the conditional distribution of straight A's for each level of student. So straight A's for the undergraduate level. Undergraduate level should be 240, 240, 240 about. So 200. So given that they are undergraduates, how many got straight A's? Okay. So in undergraduate, we see 240 got straight A's. So now how many undergraduates are there? 300. So 240 out of 300. Okay. 240 out of 300. Okay, I'm sorry. Yeah, 80%. So 80% got straight A's. And how many did not get it? Actually 60. So 60 means that it should be about 20%. Okay. And for the graduate students, we see, uh, oh, I'm sorry. 20 is actually incorrect. I was, yeah. Okay. 20, 240 is actually 240 out of 300 got straight A's. Yes. 80 got straight A's. And then 20 got, yes. So 20 should be here, I think, if I'm not wrong. Let me just check. Right? Because yeah, we're just taking the straight race. So straight race, 240 by 300, 60 by 300. Okay, and then 3760 in the next one by 4200 and 440 by 1400. Like that's how we map out to see like in the percentages how much did they get. So 3760, 84, 85 point something something. They don't say here anything. Well, I think that should be 85 point 85.5. 85.5, yes. Graduate should be 440, right? Yes, 440. Let's take that out. 89.5. I see. 89.5. Yes, yes. Sorry, guys. I just made a lot of mistakes. 89.5. Yes, 89.5. Then that one should be 10.5, right? 10.5. So yeah, 10.5. Incorrect. Well, what are they? Straight A's. Do they want us to calculate based on the total condition? Let me just check, explain. Specifically, they will be two conditions. So straight A's always to any. Okay. Straight A's, yeah. Straight A's we want for conjugate to graduate and 4,000. Okay, how do they get 4,000 over here? Let me see.